Hello friends, welcome to engineering tutorial. So we'll continue our discussion on two-dimensional motion or motion in a plane. In the previous video we discussed some basic introductory concepts related to it. So in this video we are going to discuss about the two-dimensional motion in a plane of an object with uniform velocity. So velocity we all know, which is the change in position of an object or the displacement of an object divided by time, or the specific time interval in which the displacement of the object is under measurement. Uniform velocity is when the object has equal displacements in equal intervals of time. It means in each time slot, equal time slot, it covers equal displacements. Okay, it has equal change in positions. So here let's say we try to depict this whole situation graphically. Again, as it is two-dimensional motion, so let us say we have an object, okay, which is at an initial point, let's say this, which is represented by the position vector rho vector. This is the position vector of the initial point, and from here this initial point it moved to this point, the final point F, which is specified by the position vector RT vector. So the time interval is from 0 to t, whatever units, seconds, minutes, hours, well, let's say seconds. Okay, so 0 second to t second, in this time interval the object it moved from the initial point I to final point F along the blue vector. So here the initial point is specified by this position vector rho vector with respect to origin. The final point is specified by this position vector RT vector with respect to origin. So the displacement vector we all know, we have discussed in the previous video also. So the displacement vector is always the final position vector minus the initial position vector. Final point minus initial point, that is the displacement vector. Okay, position vector of the final point minus position vector of the initial point. So velocity is displacement by time interval. So simply v vector is equal to delta r vector by delta t, which is equal to rt vector minus rho vector divided by t minus 0, because the time interval is from 0 to t. So t minus 0. So here we can write rt is equal to r0 plus vt, that is here the middle step is rt vector minus rho vector, that is equal to v vector t, or rt vector is equal to rho vector plus vt. Okay, so this basically it means this is the final position, this is the initial position, and this is the displacement in time t. So it was initially at this position r0, it covered a certain displacement in the time interval t, it is added to the initial position, and the resultant we got is the final position F. Okay, final position is initial position plus displacement. This is the basic thing. Now the important thing is to resolve it. Like I said, in every discussion related to two-dimensional motion, we have to resolve the parameters into their individual x and y components for easier analysis. Here also we'll be doing the same thing. Here let's say this initial point I it is specified by two position coordinates, okay, x0 and y0, the initial position coordinates. Okay, here let me write I is specified by x0, y0, and the final point F is specified by the position coordinates xt and yt. As you can see here, the initial position specified by the position coordinates x0 and y0, the final point specified by the position coordinates xt, yt. So we can write it in vector form, the initial point position vector r0 as x0 I cap plus y0 j cap. Similarly, rt we can write it as xt I cap plus yt j cap. Again, please pay attention to this green vector, which is the average velocity vector, which is parallel to the displacement vector. We have discussed it in the previous video. The average velocity vector will always be in the same direction, that is parallel to the displacement vector. So here we got that rt vector is equal to r0 plus v vector multiplied with the time interval. So again we know that the velocity vector also has its two individual components, x component and y component. Let's say the v vector, the average velocity vector, that is equal to vx I cap plus vy j cap. So we have the vector representation of the initial point, the vector representation of the final point, and the vector representation of the velocity vector. And we have this relationship, rt vector is equal to ro vector plus v vector into t. So if we substitute the values here, okay, so rt vector we substitute with xt I cap plus yt j cap, which we have done here. This rt vector is okay, rt vector is equal to this xt I cap plus yt j cap, ro vector x0 I cap plus y0 j cap, and v vector we have substituted with vx I cap plus vy j cap. Okay, we have expressed it in terms of their x and y components. So again, rearranging these terms, bringing the I, related coefficients on one side and the coefficient of j cap on the other, we have this x0 plus vxt I cap plus y0 plus vyt j cap. We have simply rearranged the terms, bringing all the coefficients of I cap on one side and the j cap on the other. Okay, this is the coefficient of I cap and this is the coefficient of j cap. This is the x component, this is the y component. Okay, so when we compare both sides, we have xt is equal to x0 plus vxt and yt is equal to y0 plus vyt. So the total displacement along the x-axis after a time interval t is the initial position along the x-axis or the initial x coordinate plus the total distance or the total displacement along the x-axis. Okay, displacement along x-axis. Similarly, the final position along the y-axis, that is the initial y coordinate or the initial position along the y-axis plus the displacement, the net displacement along the y-axis. Here see, this is along the x-axis, this is the final position along x-axis, this is the initial position. Okay, this is the initial position x0, this is the final position xt, all measured with respect to the origin. So this gap okay, between x0 and xt, that is equal to vxt, okay, vxt, this much from here to here. Vxt added with x0, that gave us xt. Similarly, here along the y-axis, this is the initial position, this is the final position, all measured with respect to the origin. This is the initial position, so the net displacement along the y-axis is this much, which is equal to vyt. So y0 plus vyt, that gives us yt, okay, this. So here this vxt, this represents, okay, this vxt, it represents the change in position, or the component of change in position, the position vector along the x-axis. So this is the change in position along the x-axis, okay. We know displacement, or change in position, that is equal to product of velocity and time. So here we have just done it with respect to the individual axis. So change in position along the x-axis, that is the component of this along the x-axis, this vector, this blue vector, its component along the x-axis, here this one. This is delta rx, and this is delta ry, this, okay, this one, okay. Similarly, vyt, that is the component of the displacement along the y-axis, or the change in position along the y-axis, okay. As the object, it moved from the initial point to the final point, okay. So this is what it represents. Same thing here, the displacement along x-axis, displacement along y-axis, the initial position plus product of velocity and displacement, okay, initial position plus product of velocity and displacement, which is the net change in position, that gives us the final position. So here we just did it for the individual x and y components, okay, x with x, y with y. And when we combine all of them together, we have this, RT is equal to R0 plus VT, this, taking both the x and y component together, combining them, okay. RT is equal to xt I cap plus yt j cap, R0 is x0 I cap plus y0 j cap, V is Vx I cap plus Vy j cap. Here only thing which we have done is divided them or resolved them into their individual x and y components, so that it becomes easier for our analysis. Okay, this. Okay, so this is the whole thing about two-dimensional motion in a plane with uniform velocity. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.